300 kilograms of equivalent on CO2 per meter cubic of concrete you make. And now you multiply it on the very large metric tons that we produce worldwide. And then you have your answer, 8% of the contribution for global emissions.
Hi, everyone. Welcome to the Climate Confident Podcast. My name is Tom Raftery, and with me on the show today, I have my special guest, Ana. Ana, welcome to the podcast. Would you like to introduce yourself?
Hi, Tom. Thank you. Thanks. Sure. Yeah, my name is Ana Luisa. I'm a Portuguese by origin, and I work at Paebbl. At Paebbl, I lead the VP of products. What that means is actually I support the product introduction, at the same time accelerate the product development of the materials to better fit on the application.
And Ana, for people who are unfamiliar, what is Paebbl?
Paebbl is actually a super nice company. It lays on the intersection between climate tech and building and materials. So that's makes it super interesting on the sense we capture carbon. The focus of the company is actually to sequester the carbon in something which becomes permanent. And with that, we make a material that can be used in different applications on building and construction. Mainly functions for cement applications and concrete, which is one of the most used materials in our society.
Okay, great. So let's start with the kind of heavy industry, concrete you mentioned, and the ways to decarbonize it. How do you see the core challenge with concrete and cement today? Why has that sector been so hard to clean up?
Yeah, I think we've not even started. So the focus came in the last years. So it's a very versatile material. It's actually cheap as well and makes it so interesting. And that's why we can build so much. It gives us shelters, it gives us properties to protect us from the cold. And it can be used all sides of the world. So it actually is used to grow the society and to grow the infrastructure. To your question, right now we are looking at the material and we are looking how do we make the material. And I worked previously in other industries with being in this transformation, automotive being in that transformation from fossil motors to electrical powered vehicles. I think packaging also being in that transformation. I think the transformation now is coming to building and constructions. Can we build better? And if you look to concrete, it's mainly made of 4 ingredients. So you have water, you have big stones, aggregates called, you have sand and cement, and other small part of additives and fillers. So the main contribution is actually cement. Cement is made in an old-fashioned way. We're doing the same way more than 100 years. We burn limestone, and then by that process, half of the material goes to CO2. We make CO2 of it to get the chemical properties, and we use quite a lot of energy to do so because it's done at very high temperatures. So that gives you, to give you some numbers, you're talking about 800 average, 800 CO2 equivalent, so amount of CO2 that you use to make that product. And then you use that, you put it in concrete that behaves as a nicely binder glue to give the performance of concrete. That in itself gives you then the overall average of about 300 kilograms of equivalent on CO2 per meter cubic of concrete you make. And now you multiply it on the very large metric tons that we produce worldwide. And then you have your answer, 8% of the contribution for global emissions. I don't think we are dimming down. We are building up as we grow. Society is developing. We are actually growing as a population. And in order to address that, I think one of the challenges that we have here is, can we look to the way we built? Can we make it better? Can we actually redesign this mix? And this is where Paebbl actually comes in. The material can partially replace cement. So what does that mean is overall, you can remove a bit of this ingredient, right? Which actually has a large CO2 emissions, and then you use Paebbl as such. And by that, you can actually reduce and make a low carbon concrete. And in addition, you do something unique, which is actually you use building an infrastructure to actually store the CO2, which was previously in the air or previously emitted, in a very useful way, because the alternative is actually, right, storing it under the ground. So why don't we can make something useful out of the material? So that's a bit how the challenge is and how Paebbl can fit on addressing some of the challenges on the long term to make us more resilient and climate adapted.
So you've got a drop-in substitute for cement, or partial substitute for cement from what you're saying. What's it made of?
It's actually made of a mineral. So the beauty here, and I think with many inventions or many technologies developments, are inspired in nature. So we did the same. We got inspired by nature. Mineralization is done in nature, which is the base of the technology at Paebbl that we developed. We use water, a rock, a silica rock, fine grinded, plus blended in together with CO2. We use very unique conditions of settings of temperatures and pressures, and also some small magic that we developed at Paebbl now with our scientists. And from there, you get this material that comes out, which comes directly in the powder form that can use, as you correctly said, to partially replace cement. So that's how we made it. It's a very high-tech, powered by nature. So with the ideas that nature had, the difference is we accelerated millions of in the time unit. So in the nature, that process is very slow. It takes time, and then the carbon is absorbed in the rock. We do that in a very fast pace, and by that allow us to produce the material that we do. And there is another nuance here, which is very interesting as well, which is the energy that we need to use can be then recovered, because the reaction, it's actually a chemical reaction.
Mm-hmm.
It generates energy that can then be reused again in the process, which makes our overall life cycle of the product actually negative. That's the difference, and that's the uniqueness then of what we're doing here.
Interesting. And you say it is a partial drop-in replacement for cement. Roughly how much of the cement are you partially replacing?
Today we can replace up to 30%. So for us, and I think that's the way I approach the introduction to the market. I think it's important to look to decarbonization and new materials, but focus in performance, right? If we replace, but then the performance is not the same, and you cannot build in the same way, then we need to rethink. Technology and the stages of development allow us to do so. So in order to retain performance, we today advise up to 30% replacement of pure cement. We plan to extend and evolve. This is our generation 1 product. We want to have more and more replacement, but that's part of our development process, what we are doing in our labs here at Paebbl.
And you're putting the CO2 into Paebbl so that it is already embedded when it's put into the buildings. Is that it's not that it absorbs CO2 when the building is built, it's that it's actually already embedded in the Paebbl when it's put into the concrete.
Yes. So it's a chemical reaction. So you have CO2 in the gas phase, and we make it in a stable phase, which is a carbonate, CO3. So we solidify it. So it's permanently bound, and yes, correctly, as you said, is inside the material, which is different than what you explained. If there is a lifetime of absorbing during the building, that's a different phenomena here. It's entrapped, as we call it, is actually chemical bond and transformed in a more stable material, which is a carbonate.
And where are you sourcing the CO2?
The focus of the technology is the storing part. There is several companies doing the capturing part. So it can be from single point captured, it can be from direct air capture. So for us, it doesn't really matter, to be honest. We partners with companies that do that. We receive that CO2 and we're focusing on the storing part.
And what's your view on accelerated mineralization as a pathway? You know, what makes it compelling compared to other decarbonization approaches?
I think what makes it interesting is the permanence. I don't like the word of comparing myself with other paths. I think we as a humanity need all the paths, all shots on goal. Unfortunately, we did so many damage that it's not correct to say, okay, this is better than the other. I have my personal opinion in several. One's maybe more stronger than others. Specifically on mineralization, which is the one that I work for, I do think that the beauty there, it is permanently stored, right? You can recycle the concrete. It doesn't get released again. You can just mechanical recycle it. You can put it back again. It's in the different solid form. So that permanence for longer time, because building the design of infrastructure is actually designed for 50 years or more. One of the most larger applications that we humans use, right? Because if you look to paper or cars or consumer goods, the lifetime you're talking about 2 years, 5 years.
Mhm.
In construction, the beauty is architecture stays for many, many, many years. So that gives you the permanence. In addition, you're taking the CO2 and you do something that actually lasts, long lasting, and you can actually make a use out of it. That's one of the motivations why Paebbl it becomes such an interesting pathway, because you can do the two things, right? You can lock the CO2, can make something useful out of it, and redesign materials in a more smart way. So that's, I think, gives you that benefits compared as in this specific pathway. But I do think that we need to work in all different pathways. One of the beauty, and I think linked to the technology, is we have now so many technologies, so many digitalization paths. We should use that in order to rethink what we do, right? And to rethink the environment, the objects you use, the houses we're living, the way we actually live, in order to make us more climate adaptive and better. And not only that, but also resilient, right? Because making us effective, the use of less materials will also make it more efficient and use better the resources. So you can get the best of both worlds, as I said.
The construction industry is notoriously, well, A, analog, but B, conservative. How are they going to take to a new material, especially one that's going to be put into structures that people rely on for safety, for shelter, whether it's housing, whether it's bridges, whatever? How do you ensure that it's got the same performance criteria as regular cement or concrete?
Test and test again, and you test again. So in a very simple way, that's what we do. Of course, it's the way we do it. We actually use the data, what we call the metadata, from all the tests we do, and we're learning not on our own small world. We are very keen at Paebbl to use an approach which is called open innovation, right? So we collaborate and partnerships with our customers, with the larger construction companies in the world, with the cement producers, and also the building owners. Together, we do plans for development. We use our own labs to be their extension of their R&D. And we test the material in all types of conditions, also in real life type of conditions. So we expose materials to heat, we expose materials to long weathering, to cold, in different accelerated tests, in order to prove actually the performance. So we have very strict methodologies to test the materials, and we use the knowledge of our customers, which knows even better how it's going to behave in certain performance, in certain environments, So in order to actually answer that question. What you mentioned for me is a very interesting, I do agree, it's a very conservative, probably one of the industries. As I mentioned, I work in several industries. I will say pharma, it's maybe a little even more conservative, but construction it is. And there is a good reason for that, as you mentioned. Right? So if you build a house and you stand behind the house, you have a roof in front of you, or a bridge, or any infrastructure, you need to assure that it lasts, and you cannot have accidents. It can cause very serious even deaths, right? So that's one of the reasons why the industry is conservative. If you understand that, right, as a developer, is our duty to answer to that concerns. Okay, you are introducing a new technology. We're going to take some what I call calculated and controlled environment risks, right? We're going to do small pilots, small applications from low risk application, and you gradually learn. This is the way that we did before, right? And you do that in a very controlled and educated way. And I think the beauty, what we are in the era we are now, is you can use a lot of tech to help you. So you have, of course, the buzzword AI, which means just that the models learn faster. Before, it took us ages to assess material performance. We were many, many hours looking to data, how to see the connections. Right now, we can see the connection in minutes. We can put sensors in the material, right? We have educated way of building. That way, you actually give proof and data to your customers and actually to the people build that the material works, and that actually you are introducing a technology without disturbing the performance, which I think is very important for us. And in my perspective, very important to any technology you bring to the market, right? It needs to be safe and it needs to perform. And at the same time, and that's the third variable we bring in our era, it should not harm the environment or minimally harm the environment.
And do you have a feedstock flexibility, natural minerals versus waste streams. You mentioned that buildings can be recycled at end of life. Can you take that in? What kind of flexibility do you have there with the feedstock?
Yeah, so the technology is actually a platform and it is very versatile. So we started one specific mineral, but it can be applied with different minerals. At our research facility, we test more than 20 minerals and what you call waste streams. So yes, it works. It of course has different efficiencies, and we try always to focus on the scalability of this tech, right? You're talking about an industry with a lot of metric tons. Sometimes you want to get lost with all the zeros they put of the million metric tons you produce in order to supply to the demand of the construction. So today we use a mineral which is widely available in Earth, but we can use mild tailings recycles. It's about developing. As you might understand, for developing technology, we also need focus. So we put focus on the mineral which has actually absorbed quite a lot. So you're talking about per each ton of the material we produce, we absorb about 200 to 300 kgs of CO2 today. And based on that metrics, we can then choose the mineral. But the reality is you can use this as a platform to apply to different minerals. And we do truly believe that is scalable and actually can solve the supply problem as well on low carbon materials.
The other factor that obviously needs to be taken into account, which we haven't talked about yet, is the cost. So how is the cost comparison with using Paebbl versus using standard cement?
Yeah, it's the question I receive in every single call. So I'm happy to deep dive. We, of course, thought about it, right? So we are entering the market. We have a couple of years on develop of the technology. So today, as we are on the scale up path, we don't have the largest scale to bring that cost down. So that industries that have been there before. So the way we are approaching, we have what we call a cost down curve, and we plan to be competitive up to in 2028 when we build our next plant, which we call the first of a kind on this technology. There, where we're gonna land in very competitive prices today compared to what cement is now put on the market. So that's our landing cost. We do understand that's very critical, right, to material adoption. I think more and more you talk about, startups capitalizing on green premiums. This is a very complex topic because on one way you're developing technologies. So yes, there is extra cost. Yes, we are reinventing industries that spend many, many years on cost optimization, right? Cement has been spent the last 25 years on cost optimization, right? So that needs to be put in perspective. But we understand that it needs to be cost competitive at the long shot, and we understand that the industry cannot just uptake green premiums all the time. So that's very clear. So in our pathway to the cost down on optimization these processes, we want to land closer to the cement prices.
So Anna, I mean, you talk about, or Paebbl talks about on your website, learning velocity with like sensors everywhere, cloud connected reactors, digital twins. How is that changing the pace of improvement?
Yeah, it's actually accelerating. So if you see how do we develop in the last 2 years, right? We went from micro scale to a demo plant, which can produce up to 1 kiloton of material. And this was only possible because we have, of course, tools that help us accelerate and minimize the amount of experiments and educate our views with models. Sensors also on the application side. If you use sensors to understand how the reaction behaves and how is the strength in concrete, for example, you don't need to wait for the long time of the testing. You still need to do testing. So let's be honest, I think models only work as good as they are validated. It was the same that happened with all these learning models. It took them some time until they fine-tuned. But what you see now, as we learn and we teach and we actually validate the models, more and more they get a really aid to help us develop it faster. So that's the fact. And I really hope that sooner rather than later, if you want to test the strength of a material or if you want to comply, and that's another interesting topic, a regulatory perspective that can they accept models instead of real experiments, right? Right now, if you want to know if a building will survive to a earthquake, you have to go and shake, make huge facade, huge investments to prove that the material is correct. So I think where we wanted to go is, can we actually use models to give us the trust that you can just model the conditions and actually predict performance? is done in other industries. Automotive is doing that. Pharmaceutical is doing that. So they are screening ingredients at the speed of light, as I say, in order to accelerate developments that before you used to take many, many years. I do think construction is in that path. We are starting that, but it's the beginning. But there is, to answer your question, a lot of tech and a lot of tools that we can use. And with Paebbl, we try to be as is part of our heartbeat and as you need as a startup. That's actually why the beauty of startups, right? You can actually develop faster and use the top-notch technologies to help us on that process. So we are definitely capitalizing on that. We have a large team of data and digitalization crew on board to help us accelerate and, as we say, augment our knowledge and technology development.
And in taking in that data, was there anything that surprised you when you first saw data from live operations?
Yeah, I will not say surprise. Every day is a learning. So I say there is no boring day in Paebbl. Every day we learn something new. We learn something really fast. I think we are developing a new material. So it was not there before. It was in nature, but not necessarily used in an application. So every experiment, every model run, every time we learn something, and that's not really a surprise. It's just a very exciting moment when you learn and you see, oh, this is how it works. How do we make it better on that way? And how can we actually use it on the customer demands, right? How can we provide a solution? Because that's what we are here doing. So it's a very interesting and never a boring day.
And when you see things like the EU's Clean Industrial Deal, how is that influencing scale up, especially for hard-to-abate sectors?
I think is very important is the drive as well. Is one of the drives, right? I think in Europe, that's the good parts of regulatory and push, right? It helps companies to keep their focus, right? Because if you just let the business side of it, we're just going to focus on money, that not necessarily will look to the overall picture and growth demand. That deals and other initiatives, the Bauhaus, the Green Deals, I think are very important to keep us as a humanity focus. That is not just about economics, it's also about climate adaptation, right? We need to continue living. And that brings that sharpen on that. So I do think it does help technologies and developments to put their needle also what matters. And you see the evolution of companies having sustainability reports, companies putting effort. I definitely think it'll help. The other side of the coin, sometimes we go too far. So, and we don't really align the existing regulatory with the new regulatory. So there is standardization and regulatory on materials, which not necessarily yet fully aligned with the speed we need to take clean tech technologies, but also any new type of technology in Europe. And that is what we are actually asking the regulators to be an enabler and not a blocker. I think the message is we are willing to collaborate. We will put the energy and the efforts and our brains, and we have one of them. We try to hire very educated people, a lot of scientists with a lot of tracking. So we will facilitate the data, but we are asking that they work together with us in the same way they do that policies to look to the future and how can we adapt these technologies within the existing regulatory perspective.
And you are at the moment looking to take 30% of cement out of concrete and replace it with Paebbl. Is there a pathway to get beyond 30% to 50, 80, 100?
I hope so. I hope so. And I'm sure, right? So the answer to you is, of course, there are pathways. Exactly how they're going to develop, we need to put our thoughts and our brains on that. We are working on that very heavily. And I do believe so. Where this is going to be the end, I don't know. But there are technologies. And I believe if we continue putting our efforts there, we will see a replacement. And I really, truly believe that eventually we can arrive to a carbon neutral type of material as a concrete as itself.
Okay. And where do you see the market pull coming from first? Is it from the likes of public procurement, private developers, big infrastructure owners, somebody else entirely? All of the above?
The three of them. All the three of them. So you see municipalities and cities really looking to what is a long term. And I think the municipalities and the countries and the cities, they look long term. Yeah, their job is resilience at the long term. It's not the 2, 3, 5 years, but is how is going to be my city in 10, 20, 50 years. And they have this as they pull for these solutions. They are craving for these solutions. That's everybody we talk. It's like, yes, of course. Yes, we want it, right? So if we can make better, build better at the same performance, there is no reason not to, right? So you see that there is where they seeing a little bit long term, the new building and the large infrastructures as well, pulled also from that regulatory perspective, as you mentioned, but I do think that is getting intrinsic on the corporations, to build sustainable, to build more resilience, and to look to longer term supply. So they are also asking the large infrastructure. So we see demand from all sectors, from private to public to the cities. All of them are looking to something that can help us build better. So I have to say, and that's the nicer surprise in that way, or hope, to bring us hope and positive outlook to the future, is the willingness is there. Is about how do we align all the steps and how do we do it all together and work together to make it and take sometimes some risks and maybe some extra work that we didn't plan to make it happen, and that the ideas go out of the paper and we actually make real projects. And I think Paebbl, and I'm super proud, it's been an amazing year. We made 5 commercial pilot projects in the industry, as you said before a couple of minutes ago, very conservative. We actually made buildings and infrastructure out of a new tech, a new carbon storing material. So I'm super proud, and I, not only myself, but I really thank the people that were together and work with us, our partners. And they are some of the people you mentioned. They are cities, they are large real estate owners. So one of our investors, Amazon, is also there. This is important to pull that traction, because there's nothing like belief, right? And having infrastructure there that shows that it's possible to build at the same performance.
And what do you think the construction sector most needs to unlearn if we're going to hit our climate goals?
Oh, that's an interesting question. I think that fear of trying, the sitting on the comfort, right? Oh, I did this all my life. Why should I change? And sometimes, yeah, it takes, you have the willingness in, if you are maybe at the special positions or at the customer level. But when you are seated and you are just, you are the director of the plant and you just don't want problems, you want to do your daily life. The reality is it needs to be cascaded through the organization. And that person which is running that plant needs to be also have the willing to help and to implement this type of solutions. Seeing innovation as an enabler, not as a pain, it's probably what needs to change in order to make this movement faster and to uptake these solutions, right? So I think it's even a human behavior, not necessarily. In all the industries, we adapt, right? It's very easy to, oh, it works, so why should I put the effort, right? If it works, right?
Yeah.
That's unfortunately, as humanity, we can't just afford to sit still and just, see passing by, because we will stop being competitive. And this is one of the main problems in Europe right now. We need to increase our competitiveness compared to other countries. We need to come back to that, discovery and implementing new techs. And for that, you need a little bit of, you need momentum. That's basically it. And that's one of the major things I will say. I don't know if you want to call it a shout out, just, use your knowledge. Let's go. Let's get out of the, of doing the same vanilla, always the same. Just take the risk and let's surprise for what the tech can give. What if we can even build better? What if it can be done better? Yeah, why not, right? So I think that's the message I would like to leave here.
Nice. Okay. What are the chances that we ever reach a world of carbon negative construction? And if you think we do, what's the timeline look like?
I think we are waiting for a couple of decades and a lot of effort. That timeline is linked to what we just discussed before. How much the people are willing to put effort and, and get out of their comfort zones. So it's a bit difficult to judge because unfortunately humanity has a bit unpredictable behaviors. So if you want to hope for the positive side, I think my answer is the technologies are there in the very nice mature state, and they can be uptake and they can be put and practiced and delivered very interesting results on the carbon zero or decarbonization. The time will depend just on us. I really hope for humanity and also for all of us and resilience as well, that we do it as fast as possible. But I cannot really say.
Okay. What gives you hope personally in this space right now?
What gives me hope is I have a lot of positive calls. I have a lot of people from very important companies, from very important positions in that sense, people driving in driving seats, which are asking for these solutions. People that actually see we want it. I have a lot of calls and say, Anna, we're going to make it happen. We're going to try here. We're going to try there. We're going to demonstrate. There is a lot of willingness. There is a lot of fresh blood in the industry as well, right?
Mm-hmm.
Which helps that we want to do it better. There is a lot of sense of, can we use our skills to do something for the future and leave our mark for the next generation? That's what gives me positive. That's my day is charged with that calls and it charged with that willingness. I also have some slow backs, but I do have, I think if I analyze it, the majority is there is willingness. There is a positive outlook of doing better and making better and building better for sure.
Okay. A left field question for you, Anna. If you could have any person or character, alive or dead, real or fictional, as a champion for carbon negative concrete, who would it be and why?
I don't know. That's an interesting thing. Probably some inspirational character, right? Somebody that humanity sees an inspiration. I don't know if I can name a person or name an individual. I can describe you what I could imagine that will help.
Okay.
Somebody inspirational, somebody that people will see that they can trust. They don't perceive as greenwashing, and that's a little bit the problem here. There was a bit of a blend is what is true, what is not true, what is science, what is not science. And unfortunately, the societies, instead of clarity, is sometimes fast. And I don't think that is helping in any direction. So if you describe somebody that is seen as an authority in that way, without being perceived as misleading, or that's probably what I will say. But I think you can imagine that right now it's difficult if it's a politician. I think I will tend for a philosopher, a thinker.
Oh, nice.
I think Voltaire, probably. Somebody is an inspirational more than that people can trust as an inspiration. Probably that's what I will hint.
Very good. Very good. Okay, we're coming towards the end of the podcast now, Anna. Is there any question that I didn't ask that you wish I did, or any aspect of this we haven't touched on that you think it's important for people to be aware of?
No, I think we covered quite a lot of points. I hope it was interesting for your audience. Maybe I pull back the question to you. What do you think about what I told you, and how did you felt about it?
Yeah, I think it's fascinating because the construction industry, as we mentioned at the start, is very analog, very risk averse with good reason. I mean, similar to like the utility industries is another one that's very risk averse, and again, for good reason. So it's a very challenging environment to try and make any changes. But obviously, the changes are urgent because, as you said at the start, it's 8% of global emissions come from construction. And that's a large portion. So we need to get that down. And it's universally described as hard to abate for many of those reasons. So having solutions like Paebbl being able to come in and get those emissions down, hugely important. So I think it's been a fascinating conversation. Thank you.
Super. It was a pleasure. It's always nice to talk about it and to address complex but interesting topics indeed. Thank you, Tom.
No. If people would like to know more, Anna, about yourself or any of the things we discussed on the podcast, where would you have me direct them?
So our website, our socials, our LinkedIn's, our posts, everything is around there. Please contact us. Please reach out. I'm Ana, right? So as I said, leading the product and the market introduction, but we have a full team that will be able to answer a lot of the questions. Feel free to reach out and share your thoughts. Really looking forward.
Super. And I'll put a link to the website in the show notes so everyone has access to it. Great. Ana, that's been fascinating. Thanks a million for coming on the podcast today.
Thank you. Thanks a lot. It was a pleasure. Thank you.